remember about the unit circle. When we talked about this a little bit yesterday, we talked that the unit circle was developed off of basically three angles: 30, 60, and a 45. The quadrantals were the easy parts because we knew the endpoints on the circle. What was the radius of the circle? 1. The radius of the circle was always 1, so as you walk around the circle, you had ordered pairs at 1, 0, 0, 1, negative 1 and 0, and 0, negative 1. You also, we talked real quick about yesterday, knew about how the quadrants work.
What?
X and Y values, are they both positive, both negative, mixed in quadrant 1? What do we hear? And by writing it like that, it means all of your X values are positive, your Y values are positive, X is negative, Y is positive, negative X, negative Y, and so on. Now, as we built these things out, we had three angles to worry about: 30, 45, and 60. Since we were in a circle, did we talk about any of these things in terms of degrees?
No.
No. What was 30 degrees in radians? Pi over 6, good. So we knew that at pi over 6, we dealt with a 30-degree angle. We worked with a 30, 60, 90. We knew that in a 30, 60, 90, the ratios of the sides was 1, root 3, and 2. Now, as you go through them, the ordered pairs work real nice in the unit circle. Your X values and your Y values correspond to cosine and sine. The X coordinate on the unit circle is the cosine value for that radian. Same thing with the Y value. The Y value would be the sine value. So the X coordinate, I got to find the cosine of pi over 6, the cosine of 30. Cosine. SOHCAHTOA.
Wait, can you rewrite that? Because that's so confusing. That angle is
Not drawn to scale.
okay, so the
Cosine. So you have root 3 over 2. And what's the sine of 30?
Opposite over hypotenuse. So,
1/2.
too slow.
Let's make sure we're at the same spot. We'll miss you. We go to the next one.
go back to the triangle.
Yeah,
I thought the root 3 was done.
Root 3 sounds about hypotenuse.
Right there.
Yeah. That's the point on the circle that has the terminal side of pi over 6. The ordered pair on the circle then would be root 3 over 2. It's been a while to go through a lot of this. It's been a
3, 1, and that's
This is too stressful.
yeah. And that's the whole idea of building it out. Now, if you go through and do the same thing at the 60-degree angle, 60-degree angle is what in radians?
Pi over 3.
It's the pi over 3. So if I go to the 60, that'll be my pi over 3 here. This ordered pair, well, if I look at my triangle, adjacent over hypotenuse per cosine would be 1/2. So the cosine of pi over 3 is 1/2. The sine is root 3 over 2.
It's just opposite. And then 45
Now, when you go to the 45s are the easy ones because it's an isosceles triangle. When you had the 45-degree angle, your opposites were the same. Your hypotenuse was the root 2. So if you're at 45, it was 1 over root 2, but we always rationalized it. We wrote it as root 2 over 2. Remember that? Because if you have the sine of 45 would be 1 over root 2, well, that's root 2 over 2, because you have to rationalize it down there. Sine and cosine had the exact same values at 45s.
So that's how we're gonna write it.
Yeah. Yep. That's how you should have wrote it last year, too.
But what's pi over what?
Pi over 4. Sorry, we didn't get to there. Now, what's really nice about working with a 45 is that if you know that all the way around the circle is 2 pi, halfway around the circle is pi, half of pi is pi over 2, half of pi over 2 would be pi over 4. It works out real quick because 0 to 45 to 90 to 135 to 180, each one of those is the same chunk. It's an eighth of the entire circle. Okay? So that's your pi over 4. Those 3 ordered pairs just mirror themselves into the 3 different quadrants via changing the signs, S-I-G-N. Okay? They just change the signs as they go around. Now, the weird ones come into play when you're on what's called the quadrantal. Your quadrantal angles are your 0, 90, 180, and 270.
Right?
Give us one after.
It's okay. Now you have to start. Now you have to start.
Wait, what's the 30 pi over 6?
I use the same one.
Well, I told him we'd be didn't hard, so it's okay. Well, it's not even late.
No, it's not labeled. Why would
We're
I?
gonna take a couple here.
Now, remember what I was saying earlier.
Remember what age? I had 8
Guys, come on. As you take one of the angles and you mirror that reflected over into the second quadrant, it does not change the values of the ordered pair, it just changes the signs, S-I-G-N, if needed. Going to the second quadrant, the x values become negative. The y values stay the same. So you have negative root 3 over 2, comma 1/2. Now here's the thing though. We have to figure out what this reference angle is in relationship to a radian. Remember, reference angles are always bounced off the x-axis. If this one comes up pi over 6, this one has to come up pi over 6. Well, if the whole thing is pi, what's pi over 6 less than pi?
Pi over
5 pi over 6. So this value here is at 5 pi over 6. That's how you bounce your reference angles. Everything bounces off and around. Yeah.
Wait.
Is there really any presence of radius?
What do you mean?
Like, do they matter, per se?
Well, what's happening is we're
Does
taking.
it mean anything in trigonometry?
The rest of the world uses radian versus us use degrees.
Yeah, I mean, that makes sense, but like, I'm just asking if, like,
Re-
it is used in trigonometry.
Yeah, it's more widely used than degree are because it's easier to use without a calculator. Because when you start going into these things, no matter what radian value I give you, if it's most of these values are going to be bounced out of one of the 3 angles or the quadrantal. You can always get the pair and figure out which way it's spun itself around to always get that reference angle to know what it is. So even if I asked, I don't know, 13 pi over 6, I can figure out how many pi over 6s that went around to figure out what quadrant it lies in. And since it'll have a reference angle of a pi over 6, it'll still have this same ordered pair with different signs, SIGN, depending upon what quadrant it drops to. So the whole trick.
So the radians are gonna make it easier to know what to look at.
Yeah, yeah. That's to get that reference angle. Once you know where that radian value bounces to a reference angle, the whole thing unlocks because there's really only 3 values that we're worried about. 6, okay? For each one of those x and y's. They just bounce into quadrants and signs, SIG, and change. Okay? Now, as this thing mirrors itself through, obviously the second value drops itself down. When we drop into the 3rd quadrant here, it is dropped down from pi, a value of pi over 6. So what's pi plus pi over 6?
Oh,
7 pi over 6. So this theta now is 7 pi over 6. The ordered pair still doesn't change, just the signs do because it's negative, negative. So you have negative root 3 over 2 and negative 1/2 for the cosine and sine value. Coming back over here. It's bounced off of 2 pi. Means it's pi over 6 away from it. Or 11 pi over 6. And your ordered pair, your x values become positive again, but your y value is negative. By being able to take those 3 angles, bounce them into each one of the 3 other quadrants, you're just mirroring that image to find the reference angle points. So yes, you will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different angles, but there's only 3 different ordered pairs, except for the quadrantal. I keep going back to this, and I stressed this so much last year in Algebra 2, as long as you know how to draw those 2 triangles, and know how to convert a 30 into a radian, and a 60 into a radian, and a 45 into a radian, you're going to be just fine. That's the whole idea. Okay? The only other part I really want to get into today, because I want to give you guys time to fill this thing out, is to remind you guys of the different values in the order. How do you find the sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta, in terms of x and y. Remember, your cosine values, excuse me, if I'm looking at my circle, put one up here real quick. If I'm looking at my circle, we were saying that, oops, work out well. we were saying that the theta value here was pi over 6, 30 degrees. You okay with that? We were able to draw, we didn't do it this way, but you could draw a right triangle in here to give you that. What is, can I label the radius as r? The hypotenuse is r. The adjacent value here, isn't that the x coordinate, the horizontal part? So the cosine is x over r. The sine value is the opposite over r. The tangent would be opposite over adjacent, or y over r. You guys remember that from last year? It's the same basic principle. We know that the cosine is x over r, adjacent over hypotenuse. Meaning sine was y over r. Tangent was the opposite over adjacent, y over x. Inverse trig functions. I'm assuming you remember that cosecant mirrors with sine, or is the inverse of sine, secant is the inverse of cosine, and so on. So if sine is y over r, what's cosecant?
R over Y.
R over y. Now, in terms of ordered pairs, you can also think of this as the tangent of a value when you have it on the unit circle. Oops. Oh, sorry, I'll go back. When you're on your unit circle, if I wanted to say the tangent at pi over 6, the tangent value, y over x, or you could say the tangent is sine over cosine. Remember that from trig identities? Another thing that happens. You can see that quite often. What I want you guys to do tonight, it's not in the book. I want you guys to go through your unit circle, list it all out. But I'd also like you guys to write out, whether on the back or on a separate sheet of paper real quick, what are the trig values, the 6 trig functions, sine, cosine, tangent, cosecant, secant, cotangent, for the values on the quadrantal. I didn't talk about that. But your quadrantals are your 0, pi over 2, pi, and 3 pi over 2. I want you to give me the 6 trig functions of the quadrantals tonight. And we'll continue to build this tomorrow and build into how do you continually find those reference angles and label out your 6 ordered pairs. But I want to see what you guys remember about quadrantals, okay?
What if we don't know the difference?
Yeah, absolutely. But you should be able to do it just because you have this. All right? Give those a shot tonight. And then we'll do some more building of it tomorrow. We might fill out this chart. It's kind of cool.
Oh, wait.
So we're gonna find
So like,
you gotta do the 6 trig function in class.
2 of pi?
6 of this.
This
one.
So if you're talking about on the quadrantal here, so the sine of 0, well, what's the sine of 0? It would be y over r. What's your radius always going to be? 1. What's 0 divided by 1? Okay, what's the cosine then? 1. What's the tangent? Okay, go all around. I don't know. Probably more of this stuff. Please start with you. I want to make sure Thursday the latest, Friday. Sorry, Thursday the earliest, Friday the latest. I want to do this a little bit longer than how I'm going to, because it's if you get a good grasp on how just these parts matter, the rest is so easy. It's just knowing those 3 values. And everything just trying to know a different. Who knows, it might work, it might not.
I was saying about her week. So we'll do like.
I need one more too, but I need one. I need to go right.
So studies like you pay 15? Like you didn't have a lesson?
That's what came up
Give us some
with.
time.
Oh, that was it.
Alright,